so this is the last video that we'll record, and hopefully, we'll see, but hopefully we'll be back at school after this lesson. This lesson will be for Wednesday, April the 1st. I'm not kidding. And then also, of course, we don't normally have class on Thursday, so this is Friday's assignment as well, and you'll see why. If you want to turn over to page 268 in your algebra books, 268, and we're going to be talking about applying polynomial factoring. Or in other words, as I wrote on the board, algebra in action. All right? A lot of times people ask, especially Ethan, he will say, am I ever going to use this? How does this affect my real life? And here's one example. All right? So this lesson is very short. I'm not going to do a whole lot with it, and then I'll give you your assignment because it's pretty lengthy, which will be for today and Friday's assignment. All right? And then actually, when you get back, we'll be ready for a test. I'll be sure to give it to you Monday. Kidding. All right, we'll review a little bit and see how we go. All right, but it says they're applying polynomial factoring. In other words, how can you actually use this sometimes? If you look at the example, they're going to talk about someone who's a construction or tiles or something like that, or building a room or whatever the case may be. But it says there, if you want to read it with me, in page 268 at the top, it says dimension problems. It says there in chapter 2, the word problems or application problems always produce a linear equation. That equation was then used to solve the problem. However, many word problems will result in polynomial equations of a degree higher than 1. In these cases, the factoring and the zero factory property to solve the polynomial equation. If the solutions of the equation represent physical quantities, such as length and width, some of the resulting solutions may not be possible. So, in other words, you're able to use this and find out what you need. Now, sometimes you won't get an exact answer, but it will solve your issue for whatever you are, be it construction, carpet layer, or whatever the case may be. And I say, what in the world are you talking about? Look at the example. It says this, a rectangle 7.11, a rectangle with an area of 104 square feet has a length that is 5 times more than its width. All right, so in other words, you have to lay carpet, and you're just told that the total area is 104, but you need to cut it out, the pieces out. So you need to know what the width and the length is, because 104 square feet can be one narrow passage, it can be a perfect square, whatever the case is. But they tell you, all right, it's a rectangle. And they tell you then what the total square feet is. Now, first of all, I'd have to ask you, what is the area of a rectangle? The formula, all right? The formula for the area of a rectangle is, anyone want to write on the board? Area equals length times width, all right? So length times width is that area. And so we are able to solve this now. It says the area of a rectangle where it is 104 square feet. So we know that it equals 104. Right? That is the area of this rectangle. Then it goes on to tell us that the length is 5 feet more than the width. All right, so the length is 5 more than the width. Well, what is the width? We don't know. It's x. What is the length? It's 5 feet more. All right, so now I have the total area with the length being 5 feet more than the width. So x plus 5 and x. Hope you're following this. Now I can solve this, all right, and actually figure out exactly what I need. All right, because if I go and work this out, I have 104 equals, in the little distribution here, x squared plus 5x. All right, now I'm going to take this 104 and bring it over here using that zero property factor. All right, so I'm going to minus 104 minus 104. I'm going to write it the other way around, but it doesn't change anything. I have x squared plus 5x minus 104 equals 0. Hope you're following. All right, and so now I can backwards FOIL this. I know I need x times x. I need a plus minus. And now what times what equals 104 when subtracted will give you 5. Now that one's not as easy, and I get that, all right? But the answer would be 13 times 8. All right, 8 times 3 is 24, carry the 2, 104. All right, so now I have these. Follow me? And so now I'm going to solve, and x plus 13 equals 0, x minus 8 equals 0, x equals negative 13, and x equals 8. All right, so now I have my two answers. Now, which one of these, do I want to use? I know the length is 5 more. I can use either one of these I want to, but I'll use the 8. All right? So if the width, I go back, the width is 8, all right, what is the length? It's 5 more, which will give me 13. All right? How do I know it's true? Length times width, 13 times 8 is, you want to guess? 104. All right, so you were able to find out what the length feet and the width feet is by applying the algebra. Pretty interesting. All right, let's go over to 7.11 and do that question. All right, so we're going to do the question there, 7.11b. It says the volume of a certain box is 20 cubits inches. All right, and then it tells us that the width is 4 less than the length, and the height is 1 less than the length. So what's the dimension? Well, first of all, we need to know the area for the volume, the formula for volume of a box or a cube. And that formula is volume equals LWH, length times width times height. Now they've told us that the volume equals 20. So we know it equals 20. So now we need the length times the width times the height. Well, what do we know about it? Well, we know that the width is 4 less than the length. So the width is 4 less than the length. All right, just making some notes on the side there. We also know that the height is 1 less than the length. The height is 1 less than the length. So everything seems to be based on the length. So what is the length? Well, we don't know. All right, so we're going to write this out. We have equals 20. The length is x. The width, all right, is going to be 4 less than that, so x minus 4. The height is 1 less than that, x minus 1. All right, so now I've set up my equation. I have x minus 4 times x minus 1 equals 20. Okay, and so the next step that I'm going to take is I'm going to go ahead and I'm going to work this out. All right, I'm going to solve this, FOIL that. So I have x times, and if I FOIL that, I have x squared, and then I have negative 1x, negative 4x, and a positive 4 equals 20. All right, and so now I've I FOILed that, and now I'm going to multiply my x times each of these, because I want to get to that point where I have the 4 terms, right? So I'm going to go ahead and multiply this. So I have x cubed minus 1x squared minus 4x squared plus 4x equals 20. Now I can put these two together. I forgot to put my outer and inner together. So I have x cubed negative 5x squared plus 4x. And now I have the equals 20. And I'm going to bring that 20 over, right? And so I'm going to do minus 20 equals 0. Now I have the 1, 2, 3, 4 terms equals 0, which we know we can do that by factoring by grouping. Right? And so we take this first one, and I have x cubed minus 5x squared plus 4x minus 20. Now I have my two binomials. All right, and so again, I'm going to need to solve this. I'm going to jump up here because I'm at a chalkboard. All right, so these are great. These are awesome algebra problems. All right, so I jump up here. I have x cubed minus 5x squared. With that one, I'm going to factor out the x squared, which leaves me at x minus 5. All right, follow that. On my other side down here, I had 4x minus 20. All right, so 4x minus 20. Obviously, I'm going to factor out the 4 which leaves me with x minus 5. Not quite done with this one. So we're going to now put, we have x minus 5, and then we have x squared plus 4 equals 0. Now we do that 0 factoring. So I'm going to have x minus 5 equals 0, and x squared plus 4 equals 0. This is going to be x equals 5. This one over here, I can't really do anything else to it. I can make that down to x squared equals negative 4, but you can't solve it, all right? So x is 5. So I only need one of the answers. So I go back up, and now I can solve this, all right? I know the volume of this problem was 20. So the length is x. What is x? 5. The width, all right? The width is 4 less, all right, than that. So 5 minus 4 is 1. The height, it says, is 1 less. So 5 minus 1 is 4, all right? And so now I should have this equals, we know it to be 20. 5 times 1 is 5. 5 times 4 is 20. All right, and so I would be able to know then that the volume of this cube, even though they just told me the whole volume is 20, if they say, well, what is the width, the length, and the height, I'm able to solve that using algebra. All right, so again, this is not earth-shattering, but what it is it's teaching how to put this in action. And so you can use this with our finding consecutive numbers, which we all love to do, like 3 consecutive odd numbers, etc. Or if they give you any dimensions, you're able to solve it. Let's do one of these. All right, that's really all we'll do. But look at page 271, number 1. All right, page 271, number 1. Let me erase this board while you're looking there. Go ahead and start reading the problem while I'm erasing this. All right, number 1 says this. It says a rectangle is 7 feet longer than it is wide. If the area is 144 square feet, what's its dimensions? So I know that it equals, all right, 144 square feet. All right, I know it equals that. Now, what is the area of a rectangle? Anyone? 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 Yes, area equals length times width. All right, so what do we know about the length times the width? In this problem, it says that a rectangle is 7 feet longer than it is wide. So how wide is it? We don't know, but we know the length is 7 feet more than that. All right, so the length, we don't, sorry, what was that, the length? Yeah, so the length is x plus 7, and the width is x. Then we go ahead and multiply this. And we have x squared plus 7x equals 144. All right, and then I'm going to bring that 144 over. So x squared plus 7x minus 144 equals 0. Then I'm going to break this down into 2. I have x and x. I have a plus and minus. Now, what times what equals 144, but subtracted is going to give you 7. That could take a while. The ways to find it, again, you just have to start with 1 times 144. We know that is not going to work. All right, 2 times, what would be 72? Not going to work. 3, we're not going to it. 4 will, so it'll be 4 times 38. That subtracted is not 7. 5 will not 6. Will 6 go into it? Yes, 6 times 24. That subtracted doesn't give me 7, but we're getting closer. 8, yes, 8 times 18. All right, that subtracted gives you 10. Will 9 go into it? 9 will go into 14 once. 16, 9. Will that give you 7? Yes! All right, so that's my 9 and 16. I need the larger number to be positive, so 16 times 9. Then I'm going to solve each of these. X plus 16 equals 0. X minus 9 equals 0. So x equals a negative 16 and a 9. So I'm going to take the 9. That's the easiest one to work with because you only have to pick one. I'm going to go back up here. So I'm going to have the width is going to be 9. And the length is going to be 16. And 9 times 16 is 144. And I found my answer, right? So you're able to apply that, and you're able to, solve and find what you're missing by using this algebra in action. So it's not that hard, but anyways, I'm not going to do a whole lot more of that. They have all kinds of word problems that have fun with those things, but I want to get down to the stuff that's going to be more on your test. So if you look at page 273, and don't panic when you look at it, or maybe you should. But on page 273, it's the last lesson before the end of the chapter, in which sets us up for a test. So this is a review of polynomial factoring. This will do all the types of factoring that we've done so far in this chapter. All right. So I want you to do your best on this. All right. Numbers 1 through 40, you're just going to factor them. All right. And then on numbers 41 to 48, you're going to use that zero factoring where you're going to have two answers, right? The two at the bottom, don't worry about, but I want you to do 1 through 48, all right? And that's today and for Friday, all right? 1 through 48, and get those done, and then that's all I have for you until we get back, unless they extend this break. But that's the plan. All right, so 1 through 48, and I'll tell you, I'm only going to grade 40 of them. The other 8 will be bonuses. So I'm going to encourage you to do all of them so that, if you get all 48 right, you're going to get 110. After that, they're 2 points off each, so the other 8 that you miss, they're worth 2 points. The other 8 that you don't have to do are worth 2 points each, but you can't get more than 110 because that's just weird. So you can miss up to 8 if you do all of them and still get 100. So I would encourage you to do all of them, and then we'll grade them, all the stuff when we get back. So hope you're all well, and stay in and try not to go too stir crazy. So all right, appreciate it. We'll see you then.